back. Today we're going to talk about advanced angles 2, and it involves a couple of different types of relationships in angles. The first one we're going to talk about is adjacent angles. We know that adjacent means next to, and so when we talk about adjacent angles, these are going to be angles that are next to one another, and it's going to be a set of two angles. They're in the same plane, they have a common vertex and a common side, but no common interior points. And so if I draw an angle here, and I basically put a ray in the middle, and I call it, let's get creative, A, B, C, and D, angle ABD, and angle, so ABD, and angle DBC are adjacent. Notice they're next to one another and they share that common side. That common side overlaps. A type specifically of adjacent angles would be a linear pair, and the non-common sides form opposite rays. And so if I draw these like this, just another way of labeling these angles, angle 1 plus angle 2, or angle 1 and angle 2 are a linear pair. Notice they are also adjacent angles. They share a common side. So the measure of angle 1 plus the measure of angle 2 equals 180. They form that straight line. And that's huge for us, because if they form that straight line, whatever the measures of those two angles are, we know that it's going to be equal to 180. Let's look at a couple of specific examples, and we're just going to identify these angle pairs. Tell whether the angles are only adjacent and form a linear pair, or not adjacent. Angle 1 and angle 2. So angle 1 is this one here, right? Angle 2 is this one here. Well, you'll notice they share this common side, and so these must be adjacent. And the question is, are they a linear pair? Well, do they form a line here? No, it's a curved angle. For them to be a linear pair, it would have to be a straight angle. What about 2 and 4? Well, here's angle 2, right? And here's angle 4. They don't sit next to one another. They don't really share a common side. I mean, they share this, but it's not really the right configuration. So these are not adjacent. They're not adjacent because they don't sit next to one another at all, and they certainly don't form a linear pair. What about 1 and 3? If I look at 1 and 3 here, it's going to be this blue setup here. Well, they're obviously adjacent because they share this ray BD here, right? And they're obviously adjacent, but they also form this straight line. So these are going to be a linear pair, which means they're adjacent, but together they form 180. So you can try this one on your own. Notice it's the same kind of a setup. They give you this little diagram down here. If you need to, go ahead and trace over those angles. See what you can do with those. Special relationships in angles. Complementary and supplementary. Complementary angles are two angles that have a sum of 90 degrees. Supplementary angles are two angles who have a sum of 180. I remember it like this. I look at the actual word, and this helps me remember it. Complementary, I could make this into a 90 degrees really easily. Supplementary, I could make this into a 180 pretty easily. Okay, so the complementary becomes that 9 for the 90, and the supplementary becomes that 8 for the 180. So how do we find the complement or the supplement? If I draw three angles here, And I make this one a 10 degree. And I make this one an 80-degree angle. And I make this one into a 170-degree angle. Which of them are complement, which of them are supplement? It becomes pretty easy because 80 plus 10 equals 90. So the 10 and the 80 go together, they're complements. And then the 170 plus 10 equals 180. So how do we find the complement or the supplement? Say we have 40 degrees. What is the complement of 40 degrees? So I could put complement. And supplement. You're probably thinking to yourself, well, obviously the complement is whatever you add to it to get 90, so the complement must be 50. And the supplement is whatever you add to it to get 180, so it's obviously 140. But I'm asking the question, how did we get there? And this is how we got there. The complement, we do 90 minus 40 equals 50. So 90 minus x equals the complement. Down here we did 180 minus 40 equals 140. So 180 minus x equals the supplement. That's the general rule. You take the 180 or the 90, subtract the angle that you have, and you end up with the complement or the supplement. And so when we move down here and we start to do an example, I'll leave that how do we find it up. And it asks us to find the complement of m. Well, here's angle m. So the complement of m is going to be 90 minus whatever m is, 26.8. And that's going to give me my answer, which is 63.2 degrees. Because 26.8 plus 63.2 gives me my 90. What about the supplement of n? See, now we start to mix in the algebra, the x's and the y's. What if n was 100? I'd do 180 minus 100. What if it was 150? I'd do 180 minus 150. It's the same with the x's and the y's. The supplement of n is 180 minus the measure of angle n equals the supplement. It doesn't matter that it has these n's in it. So I'm going to do 180 minus 2y plus 20 equals, and I'm going to call it the sup, so that I don't have to remember supplement. And so this is going to be 180 minus 2y minus 20, because I distributed that negative, equals the sup. And so this is going to be 160 minus 2y equals the sup. Okay? I can check this by saying, well, what exactly happens when I add n and its supplement? I should get 180. So if I said 160 minus 2y plus 2y plus 20 equals what? Well, 160 minus 2y plus 2y, these would go away, and this would become 160 plus 20 would be 180. That's what I want. I want my supplement plus my angle to equal 180. And so algebraically, that's how it works out. I want you to try this one. It's going to look exactly like that one we just did. Find the complement of E and the supplement of F. Try those. Vertical angles. What are vertical angles? Vertical angles are angles that are across from one another in an X. What does that mean? Well, you'll notice here I have these two lines that are formed by these two lines that form these angles. I'm looking for an example for you guys. Let's see. Well, all I could find was this ruler and this toothbrush. They're going to form an X here, right? And they form an X, and you'll notice when I move them this way, these side angles here, so the angles on the side, right now, they're big, but they move together. So as I make one smaller, I make the other smaller. And so they're opposite of each other in the X. So vertical angles, I could name one pair. One pair would be angle 2 and angle 4. They're across from one another. Do they appear to be congruent? Yes. In fact, vertical angles are congruent because like I showed you with the toothbrush and the ruler, they move together. So both big, 90 degrees, they get smaller together. But notice the top and the bottom also get bigger and smaller together. And so another pair of vertical angles in the picture would be angle 1 and angle 3. Okay, so these are congruent. Remember, I'm using these arc marks. So angle 1 is congruent to angle 3. I want you to do these two things down here for this diagram. Use this to name two sets of vertical angles. Try that one on your own. We'll talk about it in class. Thanks for watching, guys. We'll see you next time.